Okay, I've written the double angle formulas for all three trig functions up here, including all three versions for the cosine of 2x. So our first example, let's find tangent of 2x if we know that secant of x is 2 and the angle x ends up in quadrant 4. So the easiest way I know to do this is to draw your angle x, some version of it. We don't know exactly what angle it is, but we know it's in quadrant 4, so it might come around like this. So let's say that is angle x, and then we can draw a right triangle that meets that angle, and we want to make sure now that our right triangle satisfies the condition that secant of x is 2. If secant is 2, then cosine of x is the reciprocal of that. So we know that the x coordinate, or the cosine, inside this triangle, here's our angle we're dealing with, right? That's our reference angle. The cosine of that angle is 1/2. So we could either put 1/2 as the x coordinate here, or we could consider cosine as being the adjacent over the hypotenuse. So that's what I'm going to do to avoid fractions. So the adjacent side here is 1, and my hypotenuse I will call 2. Now we just have to figure out the length of this side, because we want to know tangent of 2x. And let me remind you of the formula we're going to use here. Tangent of 2x would be this formula right here. So if we know just tangent of x, then we can plug that number in for both of these, and we would be done. Okay, so our goal is to find tangent of x, which is opposite over adjacent. So we need this side right here. Okay, so that's what we're going to work on. So let's call it y. The Pythagorean theorem, since this is a right triangle, says that 1 squared, which is 1, plus y squared equals the hypotenuse squared, which is 4. So y squared is 3, so y is plus or minus the square root of 3. Well, since it's down in quadrant 4, the y coordinate is negative square root of 3 then. So that means that the tangent of the angle x we've got here, tangent of x is opposite negative square root of 3 over adjacent, which is 1. Well, you divide it by 1, you get negative square root of 3 anyway. So now we can say that tangent of 2x, using the formula we have up here, equals 2 times the tangent, which is negative square root of 3, over 1 minus tangent squared. When you square negative square root of 3, you just get 3. So we have, on top you have negative 2 square root 3, because 2 times negative is negative, divided by, on bottom, negative 2. Well, the negative 2's cancel out and become 1's, and you just end up with the square root of 3. Another type of problem you could do using the double angle formulas. If I want to simplify this, I notice that 2 times the sine of 18 degrees times the cosine of 18 degrees looks much like this. So I need to figure out how to make it look like this, right? Because they're equal. So what we've got here is the x is the same thing as our 18 degrees. So I need to plug 18 degrees in for this x, and I end up with sine of, I'm using the purple side here, sine of 2 times 18 degrees, because x is 18 degrees in this example, so this is the same thing as the sine of 36 degrees.